Hi guys, welcome to another one of my lectures, and today I'll be focusing on the sound waves, and this of course is a follow-up video to my initial video on wave theory where I examined what a wave is as well as properties of a wave, and then I went on to discussing light waves. Now when we talk about sound waves, we are talking about an example of longitudinal waves. And in keeping with what a wave is, it is a means of transporting energy. Now, when we discuss a longitudinal wave, we are talking about the particle motion itself being parallel to the wave motion. Now, when we talk about a sound wave is generated where, let's say, a person or a medium, let's say a speaker, right, a device, is vibrating. So I can have a speaker, right? So let's talk a little bit about, a speaker, right? And this speaker is vibrating in the surrounding air molecules. Now, when the speaker cone vibrates at the frequency that is transmitted by the electrical signal, it causes the surrounding air molecules to vibrate. Now, these molecules will vibrate back and forth, and that is how the sound is emitted. Now, the wavelength of sound is much greater than light, which is why you are able to hear around a corner but not necessarily see around a corner. So it means that sound waves can participate in all of the properties of reflection, refraction, diffraction, and interference. Now when we talk about a sound wave, we talk about different types of sound waves, right? So you can have sound waves generated from stringed instruments. You can have sound waves generated from wind instruments. Sound waves, like transverse waves, are represented by a typical sinusoidal waveform. And what you can find is that depending on the nature of sound, you can have different characteristics being deduced. What do I mean? So let's have three waves. So these three waves, A, B, and C, can be compared on something called. So now we are looking at three types of waves, and we are looking at different characteristics. So we are basing them on loudness, pitch, and quality. So when you talk about loudness, you're talking about waves that have a greater amplitude than others. So clearly wave A has a greater amplitude than wave B. So therefore A is louder than B. Now we typically consider amplitude to be proportional to the energy. So the larger the energy, the larger the amplitude. Now if we consider frequency is number of cycles. So if you notice, I did a little dotted line here. You could have seen there are about 2 and close to 3 cycles for wave B, but just 1 for A. So therefore B has a greater frequency and hence a greater pitch. So pitch is dependent on frequency. The greater the frequency, the greater the pitch. Now C talks about quality, and when we talk about how a sound wave is produced, it is the integration of many individual sound waves, and that is what constitutes an overtone, and it talks about quality. So quality is related to overtones, which on a larger sense speaks about the integration of multiple individual sound waves. Now one of the things that we have to look at is determining the speed of sound. And normally there is an experiment, so it is distance over time. So let's say we have a wall and we have a person standing some distance d from the wall, right? And we have another person here which is timing them using a stopwatch, right? This is the timer. So you can clap your hands, so you can have the person at point A clapping their hands such that they produce a continuous sound. Now when they are standing a fixed distance in front of a wall, you would have that sound traveling a distance d, hitting the wall and then being reflected back. But if you clap such that your incident wave coincides with the echo of the previous wave, you simply hear one continuous sound. So what we do is that we check the time for maybe 50 echoes. So to get the time for one, it is the time t over 50. Now, when we talk about this speed here, we are talking about the time for one echo. So therefore, the distance has to be multiplied by 2. So typically, we have this setup where your person is standing in front of a wall, they're clapping, so you hear one continuous sound, and you check the time for an echo to be heard. But obviously it's very inaccurate to get the time for one echo. So you get the time for multiple echoes, and then you divide that time by 50, and you get the time for one, for example, if it's 50 or whatever number, and then you say twice the time over the time for one echo. Okay? Alright, so let's talk a little bit now about ultrasounds. So ultrasounds are a type of sound wave that has a frequency which is greater than 20 kilohertz, which is 20,000 hertz. And most of ultrasonic waves are used in medical imaging, in particular to see the fetus in pregnant women. And it's also used to determine the depth of the seabed. And in many questions, you are basically saying that you have a seabed here, and at the top, at the surface of the water, you have a ship. And what the ship does is that it sends out an ultrasonic wave, and you then record the time it takes for that wave to be reflected and back at the receiver. So based on that, you can say the speed, and you know the speed. It's normally around 1500 meters per second at which it is emitted, and it is twice the distance over the time for the echo to be received. And based on that, you can determine